Hello! Let's move on to how to solve an example of a rational function with the slant asymptote. So, Alice was given the equation x squared minus 12x plus 20 over x minus 4. Now, right off the bat, you can tell this is a slant asymptote. Why? Because the power on the numerator is greater than the one on the denominator. So, it will have a slant asymptote. Now, our first step for this is to divide. And this will be our divisor. And since this is just x minus 4, we can use synthetic division. Alright, let's do our calculations. 4 minus 8 is negative 32. So then we are left with a remainder of negative 12. But remember, in these equations, we don't need the remainder because as x becomes really big or really small, the remainder goes closer to 0. So it leaves x minus 8 to be the real asymptote. So x minus 8 is the asymptote, slant asymptote for this equation. All right. So let's write that down. Slant is x minus 8. And since there's a slant asymptote, there is no horizontal asymptote. But there can be a vertical asymptote. And that is what we're going to try to find. So first, let's factor the equation. So we were given x squared minus 12x plus 20. So let's first factor that. That splits into x minus 10 and x plus 2. Oh, x minus 2. Let me fix that. Alright, and then over x minus 4. So, as we can see here, there are no common factors, which means that there are no holes. No holes. Let me write that down. No holes. So, in order to find the vertical asymptote, what we need to do is make the denominator equal 0. Just move that over. So, x equals 4. And, yeah, we just gotta put 4 here. Let me just actually make that more detailed. X equals 4. Now that we found that, let's find the x-intercepts. In order to find the x-intercepts, what we need to do is that we need to make the numerator equal 0. And if we just factor this out, this will be x equals 2 and x equals 10. And if we want to make this into coordinates, it would just be 10, 0, and 2, 0. So we have two x-intercepts. So 10, coordinate form, 2. Okay, now that we found that, the next logical step is to, guess what? Find the y-intercept. So, in order to find the y-intercept, what do we need to do? We need to input or plug in 0 for every x that is in our simplified function. So, just do 0, 0, 0. So, we gotta multiply that. So, it's 20 over negative 4. That equals negative 5. So, our y-intercept is 0, negative 5. Okay, now that we have found that, let's graph our function with the current data that we have in order to find the increasing, decreasing, positive, and negative intervals and find the end behavior. So let's do that. I created a one already on Desmos. Lucky you. So you don't have to do it. So as you can see in this graph, I have put down the vertical asymptote at x equals 4 and green. And in blue, I put the slant asymptote for x minus 8. Now, first, let us find the increasing intervals. So as you can see here, this entire time, it is increasing. If you see in the red lines, it is increasing the entire time. So we can write it as increases all the way to the vertical asymptote for here, and then increases to infinity. So let's just write that down. So for increasing, and remember, no brackets, only parentheses, because you cannot increase or decrease on stopping points. So it will be negative infinity because we started at negative infinity. And then we went all the way to 4 because that's where the vertical asymptote is. And then we need to do a union. And then we start once again at the vertical asymptote and then go to infinity because it was increasing the entire time. And because of this, there is no decreasing interval. None. Now, let's do our positive and negative intervals. Let's first start with negative because why not? So for the negative one, let's go back and check Desmos. For there, you see that we are negative all the way from here. And then we go negative until we reach the x-intercept 2. So, we should write that down first. So, negative infinity to 2, union. Let's go back. And then it goes from negative infinity from here all the way to the x-intercept at 10. So, it's from 4, because that's where the vertical asymptote is, to 10. So 4 to 10. Alrighty, so that is our negative, and let's find our positive. Let's erase this first so we can get some room. Alright, for our positive, here we go. So from 2 all the way up, we are positive. We go all the way up until 4. So first one will be 2, 4, no brackets, only parentheses, union. And then, from here, it's positive, so from 10 all the way to infinity. It's a lot of jumping around. Hang in there. So it's 10 to infinity. Alright, so we got our positives done. Now let's move to the end behavior. The end behavior. So, as we can see here, as x approaches negative infinity, y also approaches negative infinity. And as you can see here, x approaches infinity. As x approaches infinity, y also approaches infinity. So, let's write that down. As x approaches infinity, y also approaches infinity. And as x approaches negative infinity, y approaches negative infinity and beyond. And that right there is all the key features of a rational function with a slant asymptote. Thanks for watching.